New Syllabus Mathematics, Book 1, updated 7th edition, Chapter number 1, Primes, Highest Common Factors and Lowest Common Multiples. Exercise 2a, question number 1. Negative 0.3, 1 over 5, 0, negative 5 over 7, 4.33, negative 12, 10,001, negative 1 whole, and 1 upon 2, negative 2017, and 4. Find the given numbers, list the numbers that are positive integers, negative integers, positive numbers, and negative numbers. Now we will separate positive integers, positive numbers, and negative numbers from the given set of numbers. So first I will separate the positive integers. We know that the set of integers contains 0, positive integers, and negative integers. This set does not include fractional numbers or decimal numbers. Therefore, when considering the number negative 0.3, it is not considered an integer because the set of integers does not include decimal numbers. On the other hand, number refers to the set of real numbers which includes both rational and irrational numbers. You may also know that the set of integers is a subset of real numbers. This means that an integer is also a real number, but a real number may or may not be an integer. Now, coming to the question, the first part is negative 0.3. Now this is a decimal number. As we have discussed in detail, the set of integers does not contain decimal numbers. Therefore, I'll consider negative 0.3 as a negative number. Next, we have 0. Well, 0 is a real number, but neither positive nor negative. Therefore, 0 can't be considered a positive number, negative number, positive integer, or negative integer. Our third number is negative 5 over 7, a fractional number, which is a negative real number, but not an integer. Therefore, negative 5 over 7 is a negative number. Our next number is 4.33, a positive decimal number. As we know that the set of integers does not contain decimal numbers. Therefore, 4.33 is a positive number, but not a positive integer. Next is a negative 12. Well, negative 12 is an integer as well as a negative number. As I mentioned earlier, an integer is a number, but a number may or may not be an integer. Here, negative 12 is an integer as well as a negative number. Remember, the set of integers is the collection of 0, positive integers, and negative integers. Our next number is 10,001, which is a positive integer as well as a positive number. Our next number is negative 1 whole, 1 upon 2, a mixed number. It is a negative number, but not an integer, as the set of integers does not contain fractional numbers. The next number is negative 2017. This number is a negative integer as well as a negative number. The last number is positive 4. I think you have a clear idea about the number 4, which is a positive integer and a positive number. Second question from this exercise is to fill in the blanks. First part from this question is, if negative 6 represents 6 meters below sea level, then positive 30 represents 30 meters above sea level. The answer to the question exists in the statement. If negative 6 represents 6 meters below sea level, then positive 6 will represent 6 meters above sea level. Just as negative 30 represents 30 meters below sea level and positive 30 will represent 30 meters above sea level. Therefore, the answer is 30 meters above sea level. Second part is, if positive 400 represents depositing rupees of 400 in the bank, then a withdrawal of rupees 350 is represented by negative 350. As the processes of depositing and withdrawing are opposite to each other, similarly, negative 350 means a deduction of 350 rupees from the account. Therefore, the answer is negative 350. Third part from this question is, if negative 60 degree represents a clockwise rotation of 60 degree, then positive 30 degree represents an anti-clockwise rotation of 30 degree. If negative 60 degree represents a clockwise rotation of 60 degree, then 60 degree represents anti-clockwise rotation of 60 degree. It means clockwise is opposite to anti-clockwise, same as positive 60 degree is opposite to negative 60 degree. Therefore, if negative 30 degree represents clockwise rotation, then positive 30 degree will represent anti-clockwise rotation. Therefore, the answer is anti-clockwise rotation of 30 degree. Fourth part from this question is, if positive 45 represents a speed of 45 kilometers per hour of a car traveling east, then negative 45 represents a speed of 45 kilometers per hour of a car traveling west. Since west is opposite to the east, therefore negative 45 is opposite to positive 45. Thus, the answer is a speed of 45 kilometers per hour of a car traveling west. Moving on to question 3, the statement of the question is as follows. Fill in each box with greater than or less than symbol. It's a simple question. All you have to do is identify the largest and smallest numbers and put the less than or greater than symbol in the boxes. The first part is 16 and 60. It's very simple. Since 60 is greater than 16, therefore I'll put the less than symbol between 16 and 60. And I will read it as 16 is less than 60. Second part is 3.1 and 3.2. As 3.1 is less than 3.2, therefore I'll put a less than symbol between 3.1 and 3.2. And I will read it as 3.1 is less than 3.2. The third part is negative 6 and positive 8. As we know that negative numbers are always less than positive numbers. Therefore, I'll put the less than symbol between negative 6 and positive 8, and I will read it as negative 6 is less than positive 8. The fourth part is positive 30 and negative 30. Since positive numbers are always greater than negative numbers, therefore, positive 30 is greater than the negative 30. The fifth part is negative 2 and 0. Remember, negative numbers are always less than positive numbers and even less than 0. The more you move towards negative numbers, the lower the value of the number. Therefore, I'll put the less than symbol between negative 2 and 0, and I'll read it as negative 2 is less than 0. The sixth part of the question is 9.8 and negative 9.9. Again, positive numbers are always greater than negative numbers. Therefore, I'll put the greater than symbol between 9.8 and negative 9.9. And I will read it as 9.8 is greater than negative 9.9. Moving on to question 4, the statement is as follows. Use a number line to illustrate each of the following. The first part from this question is 2 whole 2 upon 5, 0, negative 4, 6, negative 2.8. Now, before illustrating the given numbers on a number line, let me define the number line. A number line is a straight horizontal line that represents numbers in a sequential order. It is usually marked with evenly spaced points, where each point corresponds a number. The numbers increase as you move to the right and decrease as you move to the left. The center of the number line is typically marked as 0, with positive numbers to the right. Number lines are often used in mathematics to visualize addition, subtraction, and other operations. Now, let's illustrate the given numbers on a number line. 5 numbers are given in the first part. The first number is a mixed number, that is 2 whole 2 upon 5, where the whole part is 2 and the fractional part is 2 upon 5. It is clear that this number lies somewhere between 2 and 3. I'll divide the space between 2 and 3 into 5 evenly spaced divisions because the denominator of the fraction is 5. There you can see the 5 equal divisions. Since the fraction is 2 upon 5, therefore the correct place for the number 2 whole 2 upon 5 is the small division number 2, as the numerator of the fraction is 2. The next number is 0, which lies at the center of the number line. The third number is negative 4. Here are negative 1, negative 2, negative 3, and negative 4. This means that negative 4 is located 4 units to the left of 0. Our next number is positive 6. Number 6 lies 6 units to the right of 0. The last number is negative 2.8, which lies between negative 2 and negative 3. To find the correct placement for negative 2.8, divide the space between negative 2 and negative 3 into 10 equal parts. You can then easily place negative 2.8 in its correct position. The correct placement for negative 2.8 is the 8th small division between negative 2 and negative 3. In the second part, 5 numbers are given. Let's illustrate them on the number line. Our first number is negative 0.55. To find the right place for negative 0.55, I'll divide the space between 0 and negative 1 into 10 equal parts. Next, negative 0.55 is closest to negative 0.50, which is the midpoint between 0 and negative 1. I will place negative 0.55 between small divisions numbers 5 and 6, as negative 0.55 lies between negative 0.50 and negative 0.60. The second part is positive 4, which means 4 units to the right side of 0. The next number is negative 1 over 10, which lies between 0 and negative 1. Because the decimal form of negative 1 over 10 is negative 0.1. If you look at the small divisions between 0 and negative 1, the right place for negative 0.1 is the first small division between 0 and negative 1. The next number is 2, which means 2 units to the right of 0. Then negative 2 is located 2 units to the left of 0 on the number line. The third part of this question is integers between negative 4 and positive 4. The illustration of these numbers on a number line is very simple. I'll illustrate the numbers 0, 1, 2, 3 and negative 1, negative 2, negative 3. The numbers 4 and negative 4 are not included. The fourth part of this question pertains to positive integers less than 10. These integers include 1, 2, 3, 4, 5, 6, 7, 8, and 9. Remember, 0 is also an integer, but it is neither positive nor negative. Additionally, we will not consider negative integers, since the question specially asks for only positive integers less than 10.